It all started with a paper in 2003 by Benjamin Black and Chris Pinkham. In this paper, the two would describe a potential future of Amazon's infrastructure, using standardized, automated components and web services to scale up. The paper was handed over to Jeff Bezos, who, I assume, was delighted. So, standardized, automated components all done through the web. What was meant by that? Well, instead of having to create or buy every single piece of your infrastructure and customize it, why not have a large set of generalized building blocks that can be used to build anything? So instead of creating the building materials for your house and then the house, just pick from a set of really great materials that have been put together already and build your house. You get to skip that entire middle step. Well, for this vision of infrastructure, instead of having to buy physical hardware, set it all up, deal with the storage, the networking, blah, 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 what about just a web service where we can pick and choose? And what if the services we could pick and choose from could all be used to build infrastructures equally as powerful as their physical counterparts? And if those services were standardized, well, we can create more things with them even faster because we're not reinventing the wheel. You see, in 2003, prior to this paper, the executive team apparently had a retreat, and they arrived at a very telling conclusion. Infrastructure was a major advantage of Amazon. This made sense. In dealing with scaling up their e-commerce business, keeping to scale would be a critical factor. But even though it was an advantage, Amazon found that as they were growing rapidly and hiring more and more engineers, they weren't actually building anything faster. The problem was that the teams and individuals in Amazon were building their own resources with no real thought towards reusability or scale. And so even though what they built worked great for their individual projects, it didn't really synergize with anything else. But when you have teams and teams and teams of people working in this space, you start creating an army of experts that understand infrastructure far deeper than most. And so the idea of building this operating system for the internet came to be. To quote Andy Jassy, the current CEO of AWS, if you believe companies will build applications from scratch on top of the infrastructure services if the right selection of services existed, and we believe they would if the right selection existed, well, then the operating system becomes the internet, which is really different from what had been the case for the previous 30 years. Up until this point, most of what we were doing was just traditional data centers. Buy a bunch of servers, configure them, link them up, and deploy your company's applications there. Well, hopefully you bought the right amount of servers because if you bought more than the traffic you got, you're wasting money. And if you bought too few, well, your customers are going to be pretty annoyed when they can't connect to your service. I won't go into all of the details surrounding traditional on-site data centers, but they required and require still a far greater capital investment. I mean, knowledge workers aside, you need the physical real estate, the equipment, the maintenance of the buildings and offices, janitorial services, etc., etc. There's a lot of stuff that goes into keeping these things alive. And if you're not a big company with deep pockets, how in the hell are you going to do any of this stuff for a new company? Even if you're a medium-sized company, going towards a data center is a huge investment that may not be the best use of your budget. It may not even be within your budget. Well, the Amazon team saw this as something beyond just support for their company and larger companies. And so when Jeff Bezos received that paper in 2003 describing the ins and outs of this potential path, it's no wonder, according to Benjamin Black, that Bezos envisioned a platform that would give anyone, such as college kids in a dorm room, the tools they'd need to start a new company. And interestingly enough, that idea holds very true to this day. The ability to log into a web service, pick and choose the infrastructure pieces you need, and build what you need to build, all at a very low cost in comparison to traditional data centers. And by very low cost, I mean a fraction. And so in 2004, with this idea boiling and broiling in everyone's minds, Jeff Bezos took the next step by requesting more thought to be put into the idea of selling virtual servers as a service. And so Benjamin Black wrote up another paper describing it in detail, and Chris Pinkham was tasked to construct EC2. And he went off to South Africa with a bunch of brilliant people, built the team to get it done, and started creating that first version of EC2, Elastic Cloud Compute. 2 years later, so in 2006, Amazon created its subsidiary company, Amazon Web Services, and introduced EC2 to the world. So now we know where EC2 and AWS, where they came from. But what is EC2 and how does it work? Well, to explain this, we need to rewind a bit and build it up. Sure, I can say, oh, it's a virtual server, yeah, and go the easy route, but that doesn't help us understand it. Now, I'll give a heads up. If you already understand virtualization, hypervisors, etc., this won't really be anything new aside from the history. But otherwise, stick around. So first up, let's start with a server. And now let's give it some specs. So a terabyte of storage, some CPU, memory, and an operating system. And now let's say we want to host a web application on it. And so traffic flows into the application on the server here. Well, unless, this is a really crazy application, it's probably not going to take up all of our storage, CPU, memory, and the like. And so this server may be hosting this application, but now we have a great deal of resources like CPU and storage that are unused. Now that's a waste. And right there can summarize one of the largest problems with traditional data centers, making sure that your hardware and its capabilities meet what you need. Too little and your users can't connect to your application, too much, and you're paying for stuff that just doesn't get used. Well, this is where virtualization comes into play. Now, don't get me wrong, it solves a lot of other things, but we want to narrow the scope so we don't get too sidetracked down a rabbit hole. Well, virtualization, interestingly enough, was originally tackled by IBM in the 1960s. At the time, there weren't a lot of options on computers for handling multiple users simultaneously. The popular solution to deal with it was called time sharing. And time sharing computers allowed multiple users by dividing up all of the computer's resources between the different users. A problem with this is that if any one user wrecked this system, well, everyone's system got wrecked because we were all sharing resources. And this can obviously be inefficient for a lot of reasons, but at the time, it had its place. And even to this day, it still has its place. Well, after IBM got burned on a potential partnership with MIT, they worked on and developed the CP67. The CP67 and the computers it ran on were the first commercial solutions to support virtualization. Now, what did they do? Well, the end result was that it allowed multiple simultaneous users to use one computer. They'd all get their own smaller operating system and work from that. So a lot like time sharing. But instead of splitting up the computer's resources amongst users, instead, they would all share the same resources. Now, this is a very important difference here. By sharing the same resources, we don't have to worry about splitting off too much for one user and too little for another. And also, since each user got its own separate, isolated operating system, security was far better, and changes in one user's system wouldn't impact another's. They call this technique virtual machines, making independent machines that aren't real and doing so inside of one machine. From a user-facing standpoint, it looks like you have your own workspace, but in reality, you're sharing the same physical hardware as all of the other users. And from this technique and work by IBM, the idea of virtualization, which is basically creating fake things inside of something real, but act and seem as if they're just the real thing, well, that idea dominates our entire field today. So let's hop back into our example here. This is how things look without virtualization. If you want a single server with a single application, fine. But the minute you need, say, another operating system, what are you going to do? Well, a consumer would probably just think, well, I got to go buy a new computer. But the more tech savvy know that we can get this done with virtualization. And what result will virtualization allow us to do? Well, it allows us to have more than one computer in our computer. What? Well, take a look at this image. What we have here is a computer, or a server, same thing, with two different virtual machines. One runs Ubuntu Linux, the other runs Debian. And each of the machines is running their own application. The Ubuntu is running a Node application, and the Debian one is running a Ruby on Rails application. But both are sharing the resources of the computer that they're on. Now, I get it, I know. It's a little weird if you've never seen it before, but that's all that it is. Now, how do you go about doing this? Because sometimes with the concepts, and they'll seem completely left field in terms of how weird they are. But how do you go about doing this on a day-to-day basis? Well, in modern times, you use what's known as a hypervisor. And what's a hypervisor do? Well, a hypervisor creates virtual machines. Two very popular options that I am positive you've likely heard of are VMware and VirtualBox. Both of these can be downloaded and used to create machines within your own machine, within your own personal computer. You could go get either of these tools right now and set this setup up. And the process is pretty simple. You pick a hypervisor and download it. So something like VirtualBox. Second, using the hypervisor, you carve a virtual machine out of the machine you're on. For example, I might tell the hypervisor, oh, hey, I have a terabyte of storage. Give 20 gigs of that to this virtual machine. And, oh, hey, I have 16 gigs of RAM. I'm going to give 1 gig of that to this virtual machine. So my carved out virtual machine has 20 gigs of storage and now 1 gig of RAM. Now, that virtual machine doesn't literally have 20 gigs of storage. Instead, we're just setting aside 20 gigs of storage from our own main computer that will exist as the hard drive for our virtual machine here. And when we do this, we call it a virtual drive, a virtual hard drive. The same goes for memory. We'd say that this virtual machine has 1 gig of virtual memory. But those virtual resources, so the storage and the memory, still belong to the main machine that you're running your virtual machine on. So think of it like this. When building a physical machine, you pick out the different parts and you put them together. Well, when building a virtual machine, you use the resources from your own machine to build it. And when you're done, it's like two different machines exist now. The one you're on and the virtual one. Okay. So what does this have to do with EC2? Well, a lot actually, because this is more or less exactly how EC2 works. AWS has a ton of physical hardware. They have all of their servers, and all of their hardware has a hypervisor. And when customers come to make an EC2 instance, well, what is an EC2 instance? An EC2 instance is a virtual machine on AWS's hardware. And in a nutshell, that's really what it is. When we get to it, you go through and you pick very similar things. What level of resources do you need? What operating system do you want? How much storage should it have? And though AWS does a great job of making it feel like we're constructing a physical server, we're just carving out a virtual machine in their hardware. It's really that simple. Of course, we had to take quite the path to get here. And so the process and workflow that we take as users of AWS EC2, well, we pick the attributes of our virtual machine, also known as an EC2 instance, and then we launch it. And so no matter how loopy or confusing things in EC2 become, just remember this. All we're doing is setting up a virtual machine on AWS's hardware. We pick the attributes about it, and we launch it. But it's important to understand that you're launching a virtual machine and not a physical server. This is such an important distinction because though we get, incredible levels of convenience, there are some trade-offs. The trade-offs are pretty straightforward. Obviously, we can't tinker with the settings beyond our virtual machine. Now, this isn't entirely true since AWS has added options that do allow you to rent out entirely isolated hardware and even tweak some of the deeper configurations. But the majority of things launched in AWS, well, it's usually a virtual machine on a server with a bunch of other virtual machines, where your server is one virtual machine of many. And the benefits are, well, all the things we've talked about: cost, ease of use, ease of configuration, shorter time to launch, and so on. However, from a user-facing standpoint, it's just like getting a physical server. We can log into it, we can install things on it, we can direct traffic to it, anything. It's virtually a machine. It's a virtual machine. All right, with that out of the way, we'll now dive into the actual tech project itself. The way this is going to work is that we're going to focus on the operational tech steps first, and then we'll come back and walk through everything we did slowly. This is important because although there's a lot about EC2 in practice, so creating an EC2 instance, it can be done in about 2 minutes. And so we'll do that first so that when we dive into the deeper concepts, there's less intimidation.